So you see that now here I am getting a 0. Okay, by the time I'm reaching the this 13, I'm getting a 0 here. Therefore, what I can say is, therefore what I can write is 49 is a sum of these odd numbers: 1, 3, 5, 7, 9, 11, and 13. Okay. Now there is something very interesting also that you must observe. What you observe here is that 49 has been written as sum of these consecutive odd numbers. How many consecutive odd numbers are there? 1, 2, 3, 4, 5, 6, 7. Therefore, 49 can be written as 7 square. Understood? Let's take one more example to illustrate this. Let us take a simple example this time. Let us take 36. We know this to be a perfect square, but let's check whether this is a perfect square. So 36, let's keep subtracting the numbers. Yes, we are getting a 0 at the end. So therefore, 36 can now be written as the sum of all these. Right? 36 can be written as a sum of all these. 1, 3, 5, 7, and 7, 9, and 11 also. Okay, this 11 is also included. This. What you see here, very interesting, is that 36 has been written as a sum of these odd numbers. How many odd numbers are there? 1, 2, 3, 4, 5, 6. Therefore, 36 can be written as a sum of 6 odd numbers. Therefore, 36 must be 6 square. Is this property clear? Or any questions on this property?
Yes. Yes, sir.
Yes,
Yes,
sir.
sir.
You see
Yes,
that
sir.
49 has been written as, let me just repeat this once more. 49 here was written as the sum of how many odd numbers? 7. 1, 2, 3, 4, 5, 6, 7. Therefore, 49, since 49 has been written as a sum of 7 odd numbers, therefore 49 must be equal to 7 square. Okay. So that is what. Now, suppose if I give you a question, find the sum of, suppose if I give you this question. Can you tell me the sum of this in 2 seconds? Sum of this, all this in 2 seconds. Yes, the sum of these two will be, count the number of odd numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 odd numbers. The sum has to be 14 square. Is it clear?
Yes, sir.
Fine. So we move on to the next property. Property number 8. That any square number greater than 1 can be expressed as the sum of two consecutive numbers. Now remember, this is property holds only for square numbers, not for all the numbers. So if I give you a square number, see, as I have taken in this example, suppose if I give you a number like 169, okay, I want to express 169 as a sum of two consecutive natural numbers. Okay, how do I do? What I do here is I subtract 1 from 169 and divide it by 2. So I get 168 by 2, which is 84. And I also add 1 to 169 and divide it by 2. So you get 85. So you're getting 84 here when you're subtracting 1 and dividing by 2, and you're getting 85 here when you're adding 1 and dividing by 2. Therefore, the interesting property here is that 169 can be written as 84 plus 85. But the condition here is this has to be a square number. Let us try it with 25. Simple example. 25 you know is a square number, then it can be written as sum of two consecutive natural numbers. How? 25 minus 1 divided by 2 is 24 by 2, which is 12. And 25 plus 1 divided by 2 is 26 divided by 2, which is 13. So therefore, 25 can be written as sum of consecutive natural numbers. 12 and 13 are consecutive, one after the other. 12 plus 13. Let us take one more example. Let us take 121. We know 121 to be a square number because it is 11 square. Okay. Who's doing all this? Who's not interested? You can leave. Okay, 121 minus 1 divided by 2, which is you get 60. And 121 plus 1 divided by 2 is 122 divided by 2, which is 61. Therefore, 121 can be written as 60 plus 61, the sum of two consecutive numbers. Okay, so this is the property. The next one is, whoever has done this, remove this line. Otherwise, I'll drop this class. Next, techniques of finding square numbers. Now, I have given you this technique. I have given you two examples, 43. 43 I have written as 40 plus 3. Okay, 43 I have written as 40 plus 3 whole square, and then I have expanded this by a square plus 2ab plus b square, and I have got the square of 43. Why have I written 43 as 40 plus 3? Because 43 if I write as 40 plus 3, both 40 and 3 are squares of 40 and 3 are easy to find. Okay, but if I write 43 as say 50 minus 7, these are bigger numbers. Yes, you can break it up in this manner also, no problem, because the square of 50 um, uh, is also very easy to find, and the square of 7 is also very easy to find. Okay, you can break it up this way also, but for bigger numbers there you have certain restrictions there. Okay, now because 7 would be again a big number to deal with, and 3 is a smaller number to deal with, so it is better to break it this way, 40 plus 3. And also because you're getting a negative sign here, you want to avoid the negative sign. 57, you break this up as 60 minus 3 whole square. Obviously you can break this up also as 50 plus 7 whole square. Okay, in both the cases it will be correct, because the square of 50 is also easy to find, the square of 7 is also easy to find. Now, although I have shown you this technique, now there are two techniques that I would like to show you to square any two-digit number. Okay, the first technique will apply to technique number 1 will apply, which is not shown here. Try to understand and try to practice if you can. It will apply to numbers, two-digit numbers, having 5 in the units place. This will apply only to such digits which have 5 in its units place. For example, let us say 35 has 5 in its units place, so we can square 35 with the help of this technique. Now, how to do this? See, 35 square I want to find. I see that I have a 5 in the units place. What I do here is I square 5 to get 25. Okay. Now I look at this digit 3. Okay. Now 3 I have. Now what I do is I add 1 to 3 to get 4. Okay, and then I multiply this 3 with this 4 to get 12, and I write 12. Okay, another example to make it clearer. Say I have 45. I want to find out the square of 45. So first of all, I will square 5 to get 25 here. I'll write it as it is. Next, I look at this digit 4. So 4 I have, and what is the digit after 4? After 4 I have a 5, and I multiply these two to get 20. So my square is 2025. So this is a 2-second technique to find out the squares of numbers which end in which have 5 in the units place. Any questions here? You want more examples?
No, sir.
Yes, sir. Yes,
Okay.
sir.
Let us
No,
take 2
sir.
more examples. Let us take 2 more. Say uh,
Okay, sir.
65. I want to find out the square of 65. So what I do here is I square 5 to get 25. Now I see the next digit 6. 6 I multiply it with the next digit 7 to get 42. So this 42 I write it here 4225. Let us take one more 95 square. If I want to find out the square of 95, again I have a 5 at the last place, so I write 25 square of 5, and I see this digit which is 9, and after 9 I have the next number that I have after 9 is 10. So I multiply these two, 9 and 10, I get 90. So I have, okay, so 9025 is my square. This was an easy technique for numbers with 5 at the last units digit. Now what about numbers that are in fact any 2-digit number? How will you square them? Let us take an example of 23. I want to square 23. Okay, so what I'll do is I'll first take this digit 3, square it, and write 9. 3 square is 9. Next, what I do is I take this digit 2 and I take this digit 3. Okay, and I multiply them. What do I get? 6. Now this 6 I multiply it by 2. That is double. I double 6. Multiplying by 2 means double of 6. 6 into 2 will give me a 12. Now this 12, this 2, I take the last digit of this 2 and I write it here. And this 1 that I have left, I say this is carry. Okay. Yes.
Your voice is cutting, sir.
The carry is your 1. So since I'll remember this 1. Okay. Now what I take this digit 2. I square this digit. 2 square is 4. And I had 1 in my mind, right? As carry. So I add this 1 to this 4 to get 5. So 529 is the square. Okay, let us take one more example. Let us take 32 square, a simple one. Okay, I want to find out the square of this. So first of all, what I'll do is I'll square this 2 to write a 4 here. Okay, next I'll take this digit 3 and I'll take this digit 2 and I multiply these two. I get 6. Now what is the double of 6? The double of 6 is 12. Okay, so this out of this 12, I write this 2 here. Okay, and this 1 that I have, okay, in the this place, this is my carry. I keep it in my mind for the time being. Okay, next what I do is I square this digit 3. I square this 3 to get 9, and I know what was my carry. 1 was my carry, so I add this 1 to my 9 to get 10. Any question? You want more examples?
No, sir.
No, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes.
No, sir.
Yes, sir.
Fine, let us take 2 more
Yes,
examples.
sir.
Let us take 2 more examples. This technique you will find very interesting, but if you don't practice, it is of no use actually. If you don't practice, let us take an example of 64. I want to square this number. Okay, Now, in order to square this number, first of all, I take the square of 4. But when I'm squaring 4, remember, I'm getting a 16, right? But I will not write 16 here. This is a little exception here. Okay, I will not write 16 here. I will simply write a 6. I write a 6. And this 1 that I have here, I treat it as my carry. Okay, so 1, remember, I have it in my head. It's my carry. Now what I do is the same thing. I take these 2 digits and multiply them to get 24. Okay, and this 24, after multiplying, I double it. I double 24 to get 48. Okay, so digits multiplied, doubled, I get 48. Now what I do is I had a carry 1 here, right? This 1 was my carry. I add it with this 48 to get 49. So, but I don't write 49 entirely. I only write 9. So I take this 9 and I write it here. And now this 4 becomes my carry. Okay. Next, I square 6 to get 36. 36 I got 36 after squaring 6. I had carry in my mind, which was 4. So 36 plus 4 will give me a 40. 4096. Okay. One more. Let us take a difficult number this time. Let us take 97. Now 97 is very close to 100. No point. Let us take 87. Let's take 87. I want to find out the square of 87. So what I do here is first I square 7. 7 square I get 49. Now what I do is I write 9 here. This 9 I write here. And 4 becomes my carry. Okay. Now what I do, I take these 2 numbers, these 2 digits in fact, and I multiply. 8 into 7. 56. And I double this 56 to get 112. Now this 112, I add it with this carry 4 to get 116. So 112 plus 4 will give me 116. But remember, I don't write the entire 116. I only take the last digit of 116 and I write it here. Now this 11 becomes my carry. Okay. Next, I square this 8 to get 64. Now what I do is I had 11 as my carry. So what I do is I add 11 to 64 to get 75. And I write 75. Okay. So go through this technique and practice it. If you don't practice, it's no point learning this technique. Okay, so next concept is that of a Pythagorean triplet, a very important concept, Pythagorean triplet. Now, what do you mean by a triplet, first of all? Any number, if you write any number in threes, is called a triplet. For example, if I write, say, 1, 4, and 7, this is a triplet of numbers because there are 3 numbers written together. Okay. So this is a triplet. Let's say I write 7, 11, and 13. This is also a triplet because there are three numbers. Okay. So any 3 numbers written together within parentheses or within brackets is called a triplet. Now, what is so special about these Pythagorean triplets? Now, this is a special kind of a triplet. Pythagorean triplets are special kind of a triplet. It is of the form ABC. Okay, such that the square of C is equal to the square of A plus the square of B. Okay, let us take, for example, the most simplest of Pythagorean triplets is 3, 4, 5. 3, 4, 5. This is the simplest of all Pythagorean triplets. Okay. Why is this a triplet? Because I see that when I square 5, I get 25. Also, 3 square plus 4 square. I take 3 square plus 4 square. If I take, I get 9 plus 16, which is 25. So what I see here is that 3 square plus 4 square is the same as 5 square. Therefore, this triplet of numbers is called a Pythagorean triplet. It's a special property of a triplet. Okay, Pythagorean triplet. Let us take another example. Say 6, 8, 10. Let us check whether this is a Pythagorean triplet or not. I take the last one, last of the numbers, 10 square, I get 100. And I take the other two ones, 6 and 8. I square and add them, 6 square plus 8 square. So I get 36 plus 64 equal to 100. So what I see is that 6 square plus 8 square is the same as 10 square. So therefore we say that 6, 8, 10 is a Pythagorean triplet. Any question on Pythagorean triplet?
No, sir.
No, sir.
No, sir.
I can
No, sir.
understand.
Now
I
remember
can-
one
No,
thing.
sir.
No,
No,
So
sir.
down part I can understand.
Which one?
So the down part 6 square plus 8 square plus how you have done 36
How I
plus
have
64
done? There
how
is
it's
nothing
been.
I have done here. I have simply checked. I want to check whether 6 square plus 8 square is the same as 10 square or not. So what I do is first I square 10. Okay, I square 10 to get
Yes,
100. Fine.
yes.
So I keep it in my mind that 10, the square of this number is 100. Next, what I do is I take these
Oh,
two numbers, square and add them. Okay, 6 square and 8 plus 8 square. I also see that it comes to the same. So therefore, I see that these two are same, right?
I got it. Yes, sir.
Therefore, this is a Pythagorean triplet. Okay.
Got it. Yes, sir. Got it, sir.
Now remember, in when you are writing Pythagorean triplet, suppose if I want to write 6, 8, 10, I always the greatest of the numbers always has to be written at the last. The greatest of the numbers, remember, always has to be written at the last. You can write 6, 8, 10 as 8, 6, 10 also. Okay. You can write 6, 8, 10 as 8, 6, 10. But you cannot write but you cannot write 6, 10 and 8. Because see here, this 8 is not the greatest here. So always remember that the greatest number has to be written. Just hold on.